Welcome back to the promo tutorial series. Today, we'll cover the final concept for MapleStory World scripting, events. We'll then bring everything we learned together in a simple world that we will program together using MapleStory World's tools. Let's begin. As we create our world together today, something that we'll need to utilize a lot throughout our development process is the concept of events. As the name implies, events notify certain components or scripts that certain actions have taken place. Components can send events to a certain entity that an event has occurred. Then, other components can then listen for events that occur on that entity as what are known as event handlers to process the event and turn it into actionable behaviors. In the following example that you see here, we can see 4 components and 1 entity. These components aren't necessarily attached to the entity, and the diagram is only meant to show that these components have access to the entity. The top 2 components in this first diagram send an event to that entity. Then, in this next slide, we can see that other components that have event handlers on them can listen in on events that occur on this entity. So what this means is that whenever any component sends an event to this entity, these bottom 2 components that are listening in on this entity have event handlers that will listen in on this entity and will receive the event and can process the event into behaviors. Events don't have to be sent strictly to entities. They can also be sent to a logic script, and we'll discuss these later during our guided world development. And services, which are MapleStory World's libraries that package certain functionalities for you so you don't have to develop them on your own. We'll take a look at a few of these during our guided development as well. And many other types of event targets as well. We'll mainly be going over entity, service, and logics as targets for our events during our development demo, but I encourage you to explore other forms of event targets as well from our documentation. Now that we have an understanding of MapleStory World's events, let's finally switch gears to the world that we will be creating today. The world we'll be making together is entitled Zakum's Curse. A cursed helmet once worn by Zakum has resurfaced, and it grants immense power, but drives the wearer mad, and everyone wants it. The objective of this game is to steal the helmet and be the last person wearing the helmet before the timer runs out. The wearer will be granted short speed boosts to run away from others. We can see on screen that we have a waiting area down below, and we have the game map up above. In the waiting area, players can queue up into the world by entering the portal, and once at least 2 people have joined the world, the countdown will begin, and it will count from 10 all the way down to 1. And once we reach 1, one person will be randomly granted Zakum's helmet, and the other has to try and steal the helmet before the time runs out. And once the timer runs out, one person will be named the winner, and a small congratulations message will be shown on screen. This process can be repeated over and over again, and the game can be played as many times as the players would like. Let's dive in and see how this world is created. So from the Maker's Create menu, we will click on Create New, and we'll just create from scratch because we'll be importing maps from MapleStory World's Maps library. So let's click Create New and wait for it to load. Once we've loaded in, we only need 1 map for this world, and we'll utilize the hotkey Ctrl-Alt-2 to open up our maps. And let's navigate to Fox Valley and select Fox Tree Midway 1 and load that in. It'll warn us that it'll overwrite our current map. We don't have anything in our map at the moment, so we'll just click yes and override our map. Let's name this world Zakum's Curse. Click OK. And our world has been saved. And let's actually go in and let's remove all of the portals in this world. So we'll keep all of the footholds and the ropes, and everything beyond the spawn location we will delete, and we'll get rid of all of the monsters and the portals. Then we will enter tile edit mode, and we can see this invisible foothold down below, and we can kind of click on the eyes here to double check which layer this is on. We can see that it's on layer 3, and we'll select layer 3, and we'll click on the paint box tool, and we will right click and drag to delete this entire section. And then let's go into our preset list, select our tiles, let's navigate down to a tile that we like. Let's choose tile 87. Let's click on our paint box and we'll drag And now we've created our starting area. Let's create the portal that players can use to queue into our game. We'll go into the portal section. We'll click on one of the portals. I like this one. So we'll click on portal 10 and we'll place it into our world. And then one thing that we do need is we need to designate the starting area that players will be able to teleport into. So first off, let's move our spawn location from up here down to the bottom here in our starting area. Then let's create a new object here. So we'll right click on our map up at the top and we will click on create empty entity. We'll rename this to starting area transform. And we will add a transform component as well as a sprite renderer component. And let's just select any resource as a temporary resource. We'll search for a circle. And let's just use this one and close it out. This will just be used as a visual marker so that we can click and drag this starting point around. But this will have no visual function and we will disable the visibility of this entity. But later on, if we wanted to move the position of our starting point, we can toggle the visibility back on and we can move this starting position. We will only utilize this entity for its transform component and its position in the world. Now that we have that, let's toggle our visibility off. And down in my desk, let's create a new logic script. Game manager. We've already kind of seen logic scripts with UI pop-up and UI toast, but logic scripts are essentially the same as components, with the only difference that they aren't attached to any one entity. Logic scripts can be globally accessed from anywhere, meaning that at any point in time and from any component, we can simply just reference Game Manager without having to create an entity reference or find the entity that this component is attached to, because logic scripts aren't attached to anything. So all scripts have visibility to logic scripts. So that completes our setup for our world. That's really all we need to do. We will later on go into setting up our UI, but for now, this is more than enough. So we have our level relatively set up. We have our starting area or the lobby / waiting area down below, and we have our game area up above. Now before we open up our game manager and start coding in there, let's backtrack just a little bit and revisit the concept of events. Now, one thing that I want to implement in this game is we know that when players enter through this portal, they will be teleported to this starting area up here to begin the game. However, at the moment, there's nothing preventing them from jumping right back down into the lobby. But we want the lobby area and the game area to be totally separate so that when players are in the game, they can't go back to the lobby, and when players in the lobby, they can't jump into the game. One thing that we can do is we can create a trigger box such that when any entity enters into this trigger box, they will be sent right back into our starting area transform right here. So let's keep our starting area transform visible just for now so that we can see where that is. And let's duplicate it and let's rename this respawn trigger. Let's change the sprite RUID to a different circle. So we'll search for a circle one more time. And this time let's select the red one just so it's easily distinguishable between each other. And let's drag it right around where we want our trigger box to be. Then we need to, of course, add our trigger component. And if we click on edit, we can see in green the trigger area currently. So we want this to be much, much bigger, and we'll expand the X all the way out to a point where there's no way that if anybody jumped off of any platform anywhere up in the game area, that they won't interact with this trigger area. So we'll make it a little bit bigger in the Y, just to give it a little bit more time to enter into this trigger. And this looks good to me. Let's go over one more time. We know that when somebody enters into this trigger area, they will be sent from wherever they started to enter right back up into our starting area up here so that they cannot enter into the game area down below. And we want to manually send players down into the lobby after the game is over. So we will disable the visibility because we don't want to see that during the gameplay. And let's create a component for our respawn trigger to start implementing behavior. So we'll right click on my desk, and under scripts, we will click create component, and we'll name this component respawn component. We'll double click to open it up, and now we can start adding our behavior. Within our respawn component, we want to add an event handler to listen in on events sent by our trigger component. So what we can do is we could click on this plus button, and we can search for trigger. And there's 3 different types of events sent by our trigger component. We have the trigger enter, the trigger leave, and the trigger stay. The trigger enter is triggered whenever any entity enters into the trigger range. Trigger leave is sent when the entity leaves the trigger range, and trigger stay is sent every frame as long as the entity stays within the bounds of our trigger range. We want to utilize the trigger enter event so that whenever any entity enters into this trigger area, it will be sent right back up to our starting area transform right here. So whenever any event is sent, it also sends along some parameters. The parameters for this event, we can see, is the trigger body entity, which is basically just the entity that entered into the trigger range. So we want to take this entity and we want to send it back up to our starting area here. But we want to double check also that this trigger body entity is actually a player component. The way that we will check for this is that in our default player, we know that all players have a player component, and we can actually utilize the player component to teleport the player to a certain entity. We can open up our API reference here, and if we inspect some of the properties and methods available in this component, we can see that it has a move to entity method. And this move to entity method takes in the ID of the entity that we want to teleport it to and moves it to that entity. So we can utilize this, but first we have to double check that this entity has that component. So we will create a variable named PC, which stands for player component, and we will check for the trigger body entity, and we will access the trigger body entity's player component. Now, if whatever entity entered into this trigger range does not have a player component, then this PC value here will be nil. We want to check if the PC value contains nil by using the isValid method and passing in our variable. So we have our isValid function, and we're passing in our player component, and we're double checking that it actually exists through our isValid method. Then, if it does exist, then we will call the moveToEntity method on our player component and pass in a respawn location ID. So we will create a property for this, and we will choose not to sync it because we don't need any communication between the server and the client to synchronize this value. And we will have this a string type, and we will name this respawn location. And the value for this is going to be the ID of the starting area transform. So we'll right click and we will click copy entity ID. We'll paste that into this value here. And then just like that, this should now be fully functional and hooked up. So we'll double check to make sure our respawn trigger contains our respawn component. If you haven't already added it, make sure to add the respawn component here before we press play. So we want to add the respawn component to our respawn trigger. Then let's press play. And if we drop off, we can see that every time we enter into our trigger range, it's being spawned right back up to our starting location entity, which is perfect. Before we move on, one last thing that I want to highlight regarding event handlers is the way that we listen in on events. So currently we have the thing that we're listening in on as self. Self refers to its own component. However, I told you that our trigger component is sending an event to this respawn trigger entity. So if we listen instead on the entity itself, the respawn trigger right here, and we choose to manually listen in on this entity, which is itself, and if we press play, it works just the same. The reason it works by using self is that whenever an event is being sent to the entity, it's also being sent to the component. So by listening in on the self, we're also listening in on the entity of the respawn trigger entity. This is just a shortcut. If the event that you're listening in on exists on the same component, then you can just simply use self instead of manually listening in on the entity that the event is being sent to. So with that, we have one piece of the puzzle done. We have our trigger respawn area where players, if they fall off, they will be sent right back to the starting area. Now, next we want to actually hook up the portal such that when players enter this portal, they will be sent up to the starting area to begin the game. So to hook that up, we will add that logic to our game manager logic script here. And we need to add another event handler. So the event handler that we will add this time is portal. And if you type that in, we can immediately see the portal use event happening here. If we click it, we can see that this portal use event has some events being sent, and it's just the portal user that entered into this portal. So currently, this portal use event is listening on itself. So because this game manager script is not a component and it's not being attached anywhere, listening to itself wouldn't be the correct target for this event because the portal component is sending an event to the entity that it's attached to. So what we need to do is instead of listening to the self, we need to listen for the portal entity. So this event is going to happen on this portal entity. So that is where we're going to listen for the event, and we're handling that event within our game manager. Similar to our respawn component, we are going to get the player component and make sure that the person using this portal is actually a player. If we have a valid player component, we need to teleport this player up to the starting area. Now, if we look into the space that this portal use event is being executed on, we can see that this portal use event is being executed on the client. So what that means is that when the client that uses this portal teleports to the starting location, then only that client will see the teleport and all the other clients will not see the teleport. So what we need to do is we need to let the server know that this client is using the portal and let the server teleport the player, so that all of the other clients also see the same teleport and see the player in the same location. So we will execute this on the server side as a new method. So we'll click on new and we'll name this method teleport to starting area. And we will make sure that our execution space setting is set to server so that this is a server side function. And we will take in the user ID of the player using this portal. So luckily from our player component, if we access our API reference one more time, we can see that our player component contains the user ID value. So we can simply access the player component user ID and pass that to the teleport to starting area method. So we will call self.teleport to starting area and we'll pass in pc.userid. Then from our teleport to starting area, we will grab the user based on its ID by using userService.getUserEntity by user ID. And if we want to know more about this, we can right click and click Open API Reference. And we can see that this method exists right there, and we can see the description. And we can also see some of the other methods available within our user service. Through our user service, we got the user entity on the server, and now we need to teleport this player up to our starting location. Now to do that, we will do the same thing as we've done before. We don't need to check if the player component exists because we already know it exists because we got the player entity based on user ID. So we know that it will always be a player. We have the player and we're grabbing the player component and we're calling the same method as we did in the respawn component to send our player up to the starting area. So we need to create another property here. We will choose not to sync it because there's no synchronization needed. And we will name this starting area ID. And we will copy our starting area transform ID one more time. And we'll paste that in right there. If we press play, we can see that our player is being teleported right up to our starting location. And if we open a multiplayer instance, we can see that when the other client teleports, we can see our first client also sees the teleport. So multiplayer functionality is still good to go. So now that we've got players teleporting into our starting area, we need to track the players that are actually in the game versus the players that are still waiting in the lobby. So to do this, we will create two variables and we'll choose not to sync either of these. And for the first one, we'll name it as a table and we'll create this variable name as players in game. And this will just simply track a list of all the player entities that are in our game. The second one will be an integer type, and we will track the number of players in our game. So we will name this player count, and we'll leave this at 0. Then to actually add and remove players, we will add 2 new methods, one for adding a player and another for removing a player. Both of these will need the user ID. So we'll have these as a string, and we'll name this user ID. When we add players to the game, remember that both the server and the client have their own copy of these variables, and because we're not syncing them, they will not be transferred and use resources to sync. Now, I want to make sure that when we assign our player to this player table, that we are only doing this from the server side. So we will set both of these to the server, so that whenever we add a player to the game, only the server copy is being added, and when we manipulate the player count, only the server copy is being manipulated. So that when we add or remove a player, the server has the final say, and the client won't actually do any of the heavy lifting. So to add a player, we will first grab the player by using our user service.getEntity by user ID and pass in the user ID. Then we will access our players in game table and access it by key and add it to the player. So we'll assign the players in game by the user ID key and assign that to the player entity. Then finally, we will increase player count by 1. Next, for removing a player, it's relatively the same. We will grab the player through the get user entity from user service, and we will assign the players in game by the user ID key to nil, which is Lua for nothing. Then we will subtract 1 from the player count. Then adding the player is simple. We will simply just add self.addPlayer and pc.userid down here when we handle the portal use event. Then for removing player, we will listen for one more event and add another handler here. And this handler, we will search for leave. And we can see down here, user leave event. And this event occurs when a user exits the game. So we can see that this event is executed on the server, which is exactly what we want because all of our adding and removing players is happening on the server side. So we have 2 parameters. We only need access to 1, which is just the user ID. So we don't need to do all of this business where we're grabbing the player component because the user leave event comes packaged with the user ID already. So all we need to do here is call self.removePlayer and pass in our user ID. And then it will call removePlayer and remove that from our list. Perfect. And with that, we have our whole system where we teleport users into our starting area. And we also keep track of the players in our world by adding the player or removing the player from our table. We're also keeping track of the player number by our player count so that later on, when we track for the minimum number of players required to start our game, this will be used when we set up that logic. At this point, let's give everything we've done so far a quick test by adding in a log in our add player added, and then we will log out our self.player count. So we know how many players are in our game at the moment. And let's press play. So whenever we use the portal, we should be adding a new player to the game and the number should be increasing. So in our console, we have 1 player added so far. Then if we add another virtual player, when the virtual player uses the portal, another log gets sent to our console, and we can see that now 2 players have been added. So our portal transfer and tracking the number of players in our game is all working just fine. Now that we've got that working, whenever a player count reaches a certain number of players, we want to begin a timer to count down from 10 all the way to 0, and then once the timer reaches 0, we want to begin our game. So we are now going to start developing our logic in earnest by implementing our game timer. So what do we need first to begin our countdown? Well, first we need to create the actual timer. So let's create a new variable. We will choose not to sync it. We'll keep it as a number and we will name this game start timer. And this will hold the timer when we run it so that we can start and stop it whenever we need to. Let's also create a new method. We will name this method begin countdown. And let's create create a local variable of countdown, and then let's set our game timer, and we'll utilize our timer service again. Remember, in previous video, we've gone over the timer service before. This basically scheduled a function to be called at every interval until we decide to stop it. So the function that we are going to be calling in, we will create a new local variable. We'll name this timer function, and we'll assign this to a new function. Then we will pass in our function into our set timer repeat timer function, and we will call this every second, and we will have a start delay of 1 second before the first iteration of our timer function. So within our function, at every iteration of our timer function, we want to decrease the countdown by 1, and then when the timer reaches 0, so if the countdown equals 0, then we're going to clear our timer. So we're assigning the game start timer to the timer that we've just created, and we're using timer service clear timer method to pass in the timer that we've created to clear it out to stop our timer. So this is the basic logic for our countdown. So every time our timer counts down, we want to send an event so that something like the UI, for example, which we will go into and start developing later in this video, we want to send an event so that each time our timer counts, our UI can update the timer UI. So to do this, we will create a new event. This is going to be very similar to the built-in events such as the portal use event or the trigger enter event or the user leave event. It will function in the exact same way, only it will be our own event that we create with our own parameters. So we will right click on my desk, we will go into create scripts, and we will create a new event type. We will name this event timer event, and in the property, we want to create a number of timer value. So every time our timer counts down, we want to give the timer value and send that event to the target entities so that other handlers, when they listen in on this event, can utilize this timer value and do what they want with it. So in our begin countdown function, we have if the countdown reaches 0, then we're going to clear the timer. However, in any other case, if it's currently counting down, we will have an else condition, and we want to send the event. So let's create a new function, and we will call this count event, and we will pass in the current timer. So we'll have a number, and we'll have the timer value, and inside of our begin countdown, we will call self.countEvent, and we'll pass in the countdown. So inside of our count event, we will create a local variable and name it EVT for event. We will set that equal to our timer event. So we will create a new timer event variable, and then we will set the timer value of our timer event to the timer value that we passed in. Then we will send the event to ourself. So we're sending the event to the game manager logic script. So we're going to do self.send event, and we'll pass in our event. So whenever any other handlers want to listen in on this event, they will have to listen to the game manager for the event. So keep this in mind and table it for now, because we will go back to this when we actually go into implementing our UI, because our UI will listen in on this count event. But for now, we're just going to send it to this game manager and leave it at that. We've set up our count event. However, our begin countdown currently doesn't have an execution space, and we want to call our begin countdown from our server. So we want the server to be executing the countdown, and then when it's complete, we want to send events to the client. So we're going to set begin countdown's execution setting to the server, and then when we send an event such as the count event, we want to send that to the client. So we're going to set this execution space setting to a client. So when handlers listen to the event, they're listening to the proper execution space. So because the count event is going to be sent to the client as a client-side event, when handlers listen in on this event, they will also have to be listening to this game manager from the client as well. So we have our countdown and we have our count event, but when the timer finishes, we also need to notify when the timer is complete so that we can perform some sort of behavior here. So we can utilize what's known as a callback, and our timer repeat also utilizes a callback. So if you look inside of one of the parameters is a function type. So we can also pass a function into this begin countdown and then call that function when it's complete. So we can add a parameter, and of the type, we don't have a function type. So what we can do is we can use the umbrella catch all any type, and we'll name this parameter onComplete. When the timer is done, we will call onComplete as a function because we know that onComplete is a function. So when it's complete, it will call the function. So we only want to start our countdown if there's enough people in the game. So let's create another variable up here, and we won't sync this. We'll set this as an integer type, and we will call this minimum player count. And we will initialize this variable to, let's say 2, so that we need at least 2 players to begin our game. When there's at least 2 players in our game, then we will begin our countdown. So we know how many players are in our game currently because we add our player count in our add player. So we will create a new method, and we will name this method check player count, and we will say if player count is less than our minimum player count, then we're going to just return and do nothing and then end this function. If there is at least the minimum player count, then we will continue by calling our self.begin countdown. So we'll begin the countdown and we will pass in a new function. So we'll create a new function right from within the parameter here, and we will simply call game start. So this player count, because remember, we are adding our player count from the server, we also want to make sure that when we call this function, we are executing this from the server, so that when we reference our player count, it will be the server copy of the player count. And then as soon as the countdown is done, when it's complete, we want to call game start. So this is another function that we will create, and this will be in charge of handling the logic for what happens when the game is starting, and we will create another one for when the game is finished. So we will have one game start, and we will have another one game end. Okay, so when our game starts, we want to keep track of whether or not the game is currently in progress or whether or not it is not. We want to create another variable here, and we will create a Boolean type, and we'll say has game started, and we'll say that's false. And then in our game start, we will simply say self.hasGameStarted equals true. So we'll set that to true, and of course in our game end, we will have to set that to false. And then when our game has started, we want to create another event so that we can notify something like the UI, for example, to create some sort of effect. So when our game starts, we had the game start effect showing on screen, and we want to listen in on when the game manager sends out the event saying that the game has started, so that something like the UI can listen in on that event and execute some sort of behavior like showing an effect. So we will create another event here. We'll create an event type, and we will call this game start event. And we don't actually have any values to pass in through this game start event, so we'll just leave the event parameters as empty, and we will simply create another function here, and we'll have game start event. And the game start has to be executed from our server space. So when we set our has game started equals true, we want our server to have that variable being set and not the client. So we're calling this from the server. So check player count begins the countdown, the game starts, and it calls the server function game start, which sets our has game started Boolean variable. Then we will call self game start event to create our event and send it out. We have our count event, so we're going to create a new local event and set that to game start event. And we don't have any parameters. Our timer event had a timer value parameter, but we don't have any for our game start. This is simply just an event with no parameters. Then we're going to send this again to our logic script, self send event, and we're going to pass in our event. We are passing in our game start event to the logic script so that anyone that listens in on the game manager for this event can perform behaviors when this event gets called. So when the game is started, we are calling game start event, and same thing as when we did the count event, we have to make sure that our event is being sent from the client space. So listeners on the client side will be able to listen and receive this event. Okay, so from our game start, we want to create another countdown. So we will copy our countdown here, and our countdown again is going to start from 10 all the way down to 0. And when it reaches 0, it's going to, instead of game starting, we want to game end. So when the countdown reaches 0, it will end our game and call this function. And then our game end function will be called. Game end will also be a server-side function. And similar to our game start event, we will have another event being called when the game is ended. So we will create another event, and we will name this event game end event. We'll double click to open this up. And when our game is over, we want to notify who the winner was. So we will create a variable and name this winner user ID to store the user ID of the winner. Then we will go back into our game manager, and let's create another client-side game end event. So we have a game start event and we have a game end event. This will also be from the client, and we will have a local event equals game end event, and we will set the event's winner user ID to a parameter that we will pass in, winner user ID. Then we will set that equal to the winner user ID, and then we will send this to the logic script. When our countdown is finished, we are calling game end, and in game end, we want to call our game end event. But we want to pass in the user ID. So currently, we don't have a user ID to pass in because we are in the server space and we haven't provided any information about a user ID. But eventually what we will do is we will keep track of the player currently holding our Zakum helmet. So let's create a property really quick, and we will choose not to sync this, and we will have it as an entity type, and we'll name this variable as current Zakum. And we will actually implement this entity and keep track of the current Zakum later on when we implement that logic. But for now, let's assume that we have the current Zakum and the player that holds our Zakum helmet by the end of the game. So we will simply pass in the current Zakum and get the player component and the user ID. And the last thing that we want to do is when the game ends, we want to teleport all of the current players down back into the lobby area. So we will create a new function here, and we will name this move players to spawn, and we will set this as a server so that the server can move our players so that all of the other clients are also being moved together. So in our game end, we are calling our move players to spawn. So when the game ends, we will move all the players to spawn, and then we will call the game end event. When we move a player, we will utilize the same logic that we use in our teleport to starting area, where we use the player components move to entity, and we pass in the starting area ID. This is going to be the ID of the entity for when we start the map. But what we want to do is we want to grab this entity, our spawn location, and we're going to spawn our players back into this position after our game is over. So we will grab the entity ID of the spawn location, and then we will create a new variable. We'll choose not to sync it, and we'll have it a string value, and we will name this spawn area ID. We'll paste in our spawn ID. Then down below, we're going to loop through all of our players inside of our players table. So these are all of the players that have been added to our players in our add player. So we're going to loop through the table using the key value pair. So this is all of the keys, and this is the pair at each step whenever we start iterating through this table. So we will grab the player from each loop, and we will grab the player component of it, and we will call the move to entity and pass in our spawn area ID that we've just created so that we can teleport players back to the spawn. And then finally, Since the game is over, we have to reset our players in game because there's no longer any players in the game, and also there's no players, so we will set the player count to 0. Okay, so that was a lot, but we have successfully completed the timer step of our game. So now we have a functional timer, and we have a countdown system, and we have a game starting system, we have a game starting event that other entities and other components can listen on. We also have a game end event, and we're passing in the winner user ID so that our UI or whatever other entity needs to have access to this event when it happens. They know who the winner was, and they can use that for whatever logic or behavior that they'd want. As always, we will take a moment to pause and double check to make sure everything is fully functional before we move on. So we will check to make sure that our countdown is working by doing a log at the countdown. And we will concatenate that with the countdown value so that we can know the value at each countdown. We will also go into our game start function, and we will make sure that our game start event, our game is starting. And when the game ends, we want to log that our game has ended. Let's also do a check inside our events, game start and game end, to say game start event, and then our game end event as well. So we'll check for all of these. We have our countdown value, we have the game started, we have the game ended, and then both of our events being logged to the console. So let's press play and see if this all works. So we've got 2 players. The first player is going to enter into the portal. The second player will enter into the portal, but nothing is happening and none of the logs that we've logged out to the console are being called. So let's go back to our code and double check to see what went wrong. And upon inspection, our player count is actually not being called from anywhere. So we have our begin countdown starting inside of our check player count, but check player count isn't actually being called from anywhere. So down into our portal use event, where we add the teleport to starting area and the adding player, we will also call check player count in here so that we can check for the player count, and if there's enough, we will begin the countdown. Something that I also forgot to do is when we teleport a player into the game, we want to make sure that you can only teleport into the game if the game hasn't already started, which is the reason for why we had created this has game started variable being set to true on game start and false on game end. So inside of our teleport to starting area, we will do a check for if the game has already started, then we will return and not do anything in this function. So now that we've got the player, let's also add one more log in here to say player added, and we'll concatenate that with the player count, and let's press play. And we will add in our second player. We will have the first player enter into the portal, then we'll move the second player right in. And let's toggle the collapse off so we don't get repeats, and we can see the countdown starting. Now the game has started, we have the game start event, and the countdown is starting again. And then we get the game ended event, and we have an error saying that the current Zakum is nil, which is expected because we haven't actually set our current Zakum to anything yet. But we will do that next. So that's a lot of code that we've added in this section, but just to recap, we have our players being added through our portal. So whenever our portal is used, it teleports the player to our starting area, and it simply just teleports and moves the entity there. Then we have our add player, which will add the player to our table and increase the player count by 1. Then it checks the player count to see if there's enough players, and if there's at least the minimum count or more, then it will begin our timer. And then once the countdown begins, it calls game start. And then game start starts another timer with a different callback for game ending. So on game end, we call a different function, and then when the game ends, we teleport our players back into the spawn and reset the players and the players in our game to 0. One thing that I forgot to add is in our countdown, we have to make sure that every time our countdown function is called, to clear out the timer if it's already running. So we will clear out the timer at the start of our begin countdown so that if for some reason begin countdown is called multiple times in succession, there isn't 2 timers running at the same time. So we'll just make sure to clear the timer at the start of this function to kind of prevent any errors. So once you're done testing, it's always a good idea to remember to remove all of your logs so they are not cluttering your game during runtime. So we will go back through all of our logs and we will make sure to have them removed. Okay, so now let's actually go into the meat of our game and start creating our Zakum logic. So this is the logic for when players enter the game. One person gets randomly assigned a Zakum helmet and the others have to kind of chase that person down and try to steal the helmet from them. Let's begin by first creating a new component that will be attached to the player that will be in charge of assigning the helmet, playing effects on the character, and things like that. So let's create a new component in my desk, and we will call this Zakum player component, and we will attach that to the player. We can confirm that it has been added right there, and we will double click to open it up. So first things we'll need is 3 variables here. We will choose not to sync any of them. The first one, we will need the RUID of the effect to play, when the first one we'll need is the RUID of the helmet of the Zakum helmet. So we will name this Zakum hat RUID, and the second one will be the effect that gets played when we equip the helmet. So we will name this a string, and we will name this Zakum effect RUID. And the last one we'll need is just a boolean to determine whether or not I am currently Zakum or not. Okay, so we will also need some components here. The first method is set Zakum. The second method will be unset Zakum. So as these functions name might suggest, the first one is going to equip the helmet. The second one is going to be unequipping the helmet. So if we've set the Zakum, we will set self.isZakum to true. And on unset Zakum, we will set self.isZakum to false. To equip the helmet, our default player has a costume manager component. And among our costume manager component, we have a cap equipment. So we can go into our resource storage, and we can go into MapleStory World's resources, and down into the avatar items, we can go through our cap. We will just kind of go through, and we can find our Zakum helmet here. We will copy the RUID, and we will paste that into the Zakum hat RUID field here. Then we will also search for the effect. So inside of animation clip, we will search for transform, and we have a lot of different effects here, but we want one that doesn't have the character. So we can maybe use this one. We will click on the eye to preview the effect, and we will copy the RUID, and we will paste that into our player Zakum component in the effect RUID space. And then when we set the Zakum, we will grab the self.entity, and we want to grab this costume manager component. So we will grab the costume manager component, and if we inspect the API for our costume manager, we can see that we have a set equip method that can take in the category of the avatar item and the RUID. So we will simply call that method, and we will choose the cap category, and we'll pass in our Zakum hat RUID. We can see from the Maple avatar item category, so if I remove cap and I just press dot, we can see the list of all of the different types of items available, but I've simply just chosen the cap. So make sure that you are associating the right item to the right category. And then finally, we will use the effect service and the play effect attached to pass in our Zakum effect RUID, and then it takes in what the parent of our effect will be, which is going to be the self. So the current entity that this component is attached to. The local position will be 0, so it'll be stuck right onto the same position as our character. The local rotation will be 0, and the scale will be 1. When we unset Zakum, we will simply reverse our costume manager set equip on the cap category to none to revert our equip item to its default. So let's give this a quick test. We will utilize the onBeginPlay as a temporary way. And we'll set the execution space to client, and then we'll do self.setZakum and see if our helmet becomes equipped. You can see that the item is being equipped. Then we will also check for the unequip by using key down. And this is another event that we will listen to. And whenever a user enters something into their keyboard, we can listen for the input service for the event and the key that was pressed. So if key equals keyboard key dot, let's say F, then we will do self dot unset Zakum. So the game starts and we have our Zakum helmet on, we press F, and our Zakum helmet is unequipped. So all of that is working fine. So we will get rid of our testing methods and our event. And we will make sure also that our execution space setting of this is set to our client side. The other thing is that when the Zakum helmet is equipped, we want to boost the speed of our character. So let's add a new speed setting, and we will have it as a number type. And we'll create this variable as Zakum speed. And let's set this to something like 1.5. We'll create another variable, choose not to sync it. And we'll set this speed as a normal speed and set this to 1. If you are Zakum, the speed will be 1.5. Otherwise, your speed will be 1. So let's create a new method here. We'll name this function set speed, and we will have a parameter of a number type, and we'll name this speed. To modify the speed, our default player has a movement component, and this input speed is what determines the speed of our character. So we will grab the movement component attached to our entity, because our Zakum component is attached to the player component, which has the movement component. So we will access that, and we will also access the input speed. So we'll grab the input speed of our movement component, and we'll assign the speed value. We also want to make sure that our speed is a server-side variable, because we want our input speed to be applied to all of the other characters as well. So when we call this from the server side, we will assign the movement component on the server. And because this variable on the movement component is a synced variable, it will be updated to all of the other clients as well. So using this function, when you are Zakum, then we will set the speed to the Zakum speed. If you're not Zakum, then we will set the speed to our normal speed. So when the player steals the Zakum helmet, we don't want someone to be able to immediately take it right back. What we want to have is we want to have a short duration of immunity so that no one can steal the helmet while you are immune or invulnerable during this period of time. Let's create another variable here, and we will call this variable is immune. And we actually do want to sync this. And speaking of, we also want to sync the isZakum variable so that both the client and the server knows that you are Zakum. So this variable should be synced across the client and the server so that both the client copy and the server copy will always update and sync with the proper Zakum state. So we have our isImmune variable. We will create another variable. This one will not be synced, and we will name this immunity duration. And let's give this something like 5. So for 5 seconds, you will be immune. Let's create another function here, and we will name this set immunity. And then we will set our immune to true. And then we will create a timer so that we will set the timer once to wait for 5 seconds. And then after 5 seconds, we will set our immunity to false. This will be a server-side function, just the same as our set speed. And finally, we want to implement the ability to actually be able to steal the helmet from other players. So we will utilize the trigger component that we did for our respawn trigger. We'll do the same thing for our player. So our player also has a trigger component, and if we click edit, we can see a preview of our character on screen, and we can see the trigger area of our character. You can choose to close the edit. If a character enters into the player's trigger area, we want to call the trigger enter, and we will listen in on the self because this trigger component will be sent to the self, and the handler will also be on the self. So we will get the local body entity that entered into this trigger range, which in this case should be the other players. And we will make sure the trigger handle trigger event happens on both the client and the server. So we don't want to execute any code if it's run on the client. We only want to run it on the server. We have attached to the self and any component that you make, there is an isClient or isServer function. So when this function is called, it returns a boolean of whether or not the current execution environment is a server side or if it's on the client side. So if you call isClient, then it will return whether it's true or false for the client. If you call isServer, then it will return true or false for the server. So if I am the client, then I don't want to execute anything and I want to return. Now we know that when this trigger enter event is called, it will run on the server. So we will grab the Zakum player component, shortened to ZPC. And if there is no Zakum player component, meaning that some other entity entered into our trigger range, then we don't want to execute the following code. If it is, then we will continue. If the other player is a Zakum and the other player is not immune, then we will send a new event notifying that the ownership of the helmet has changed. So we will create a new event here and we will name this Zakum changed event. And we will have one property in here of a string type of the user ID of the player that now should own the helmet. So we will create a new event of the Zakum changed event, and we will set the event user ID to ZPC to the trigger body entity dot player component dot user ID. Because we know that if we have the Zakum player component, we can assume that this is a player entity. We are also going to assume that the entity that entered into our trigger range also has a player component, and we can access the user ID field from there. Then finally, we will send the event to our game manager. So we'll call game manager send event, and we'll pass in our event. So we are sending the event to the game manager, and the game manager can listen in on events on itself through its handler to handle the event. So it will receive the user ID of the player that should now be Zakum. Last thing we will do is, since we've gained the helmet, we want to be immune for a short duration. So we will self set immunity so that as soon as we take the helmet, we are going to be immune from being stolen for a short duration of time. Okay, so now we have our trigger, we have the ability to steal, we also have immunity. So let's go into the game manager. So remember, we are sending this event to the game manager. And now from the game manager, we want to listen in on this event. So we will click on event handler to create a new event, and we will listen for Zakum changed event. And we can listen in on the self because we sent our event to the game manager itself. So because we sent our event to the game manager logic script, we can listen in on itself, and we can grab the user ID that we passed in as a parameter, and then we can start adding our logic to set this user to a Zakum. So before we can set the player as a Zakum, we will create a new method here, and we'll name this change Zakum. And we will of course take in our user ID that we will receive from our Zakum changed event, and then we want to set the current Zakum variable here that we created earlier, current Zakum, to be the new Zakum. Then we will set the new Zakum, and we'll grab the Zakum player component, and we will call set Zakum. So here we are grabbing the new Zakum, and we are setting the helmet to the new Zakum. But if there already is a Zakum, we want to unassign the helmet and we want to call unset Zakum on the current Zakum. So we will use isValid. So if current Zakum exists, then we will call self.currentZakum.Zakum player component.unset Zakum. Then down here, we can finally call self.change Zakum and pass in our user ID. We also want to double check to make sure that our change Zakum function is being called on the server, so that our current Zakum and all of our other logic is being handled and run from the server. So we also want to make sure that this is also being run from the server side as well. And now when someone steals the helmet, it will send an event to the game manager. The game manager has an event handler listening in on itself to change the Zakum helmet and remove the helmet from the current Zakum player and assign it to the new player. But in order to steal the helmet, we have to have someone have the helmet in the first place. So when the game begins on game start, what we want to do is choose a random player within our players in-game list and randomly choose a player to be Zakum. So let's create another function here and we will name this setRandomZakum. We will set the execution space setting of this to server and we'll double check to make sure that our player count is greater than 0. If it's 0, then we don't have any players in our game so far, so we don't want to set a random Zakum. Then we will grab a random user using our util logic.randomIntegerRange. So if you right click on this and go into OpenAPI reference, we have inside of our util logic a lot of different types of utilities, but inside of here we have a range where we can grab a random integer range between our minimum and our maximum inclusive. So between 1, which is the first index of our players in game, to our player count, it will generate a random index. However, something to note is that when we added the player, it is not by index, but it's rather by the key. We also have to grab a list of the keys. So we can get table.keys of our players in game, which will return a list of our keys for our players in game, and then we can pass in our random user and grab the index from the keys. So we have the user key, and then we can call self change Zakum to self.players in game, and then grab the user key, and then .player component .user ID. Okay, so we have our random Zakum being generated from our set random Zakum, and we are calling change Zakum to assign the new Zakum to our random player. So when the game starts, we want to do self.setRandomZakum. And then it will randomly choose a Zakum among our player list and then assign the Zakum to that player. Something that we have to make sure though is that when we send this event, we have to make sure that this event is on the server side. So because our function is being run from the server and the event is being run from the server, we also have to make sure in our game manager that our execution space setting is also on the server for Zakum changed event. Remember that in our trigger event, we are ignoring the client and only running this from the server. So this event is being called from the server. So our game manager also has to run this event handler from the server as well. When our game completes, we want to unassign the helmet from the current Zakum, and we will grab the Zakum player component of the current Zakum entity and then call unset Zakum. So let's say that a game is running and the player leaves, then we remove the player. If that player is Zakum, then we want to unset that player's Zakum and we want to set a random Zakum. So let's give this a play and we will spawn in our second client. We'll move our first client up to the gaming area. Then when our second client spawns in, we'll move that person to the next playing area. Then after a little bit, one person should be assigned the Zakum helmet. And then now, if I collide with another player, it should be taking the helmet, but currently it is not. So let's go back and figure out what we did wrong. So one thing we did wrong is in Zakum player component, we have our handle trigger event happening on the server side. And we do want to keep everything on the server side, but our set Zakum and unset Zakum functions are currently on the client side. So when our trigger event happens, the Zakum and immune variables are being brought over from the server copy, which is not being set. And instead, because we set Zakum on the client side, the server side is still false. So what we need to do is we need to set our setZakum function to the server side, and also the unsetZakum to the server side as well. And when we pass in our user ID, we should not be passing in the player component of the trigger body entity, which we assume already has the helmet, but instead we have to pass in our own ID so we can steal the helmet from the other person and wear it for ourselves. So we will do self.entity.playerComponent.userID so we can pass in our own user ID. And then now, giving it another play, we will move our first player up to the game area. Then we'll move our second player into the game area as well. Then after a short duration, one of us gets the helmet and I can steal the helmet. Other players can steal it. And then that person has immunity for a little bit. But after a while, I can steal it back. We have all of the core logic of our game set in stone now. So the game is fully functional and all of the pieces of our game is now fully functioning. However, now we need to add some more visual and audio elements to our world to give it a little bit more polish. So let's begin with the UI. And we will create a couple UI here. But before, let's create a new UI group. And we will name this UI group Zakum UI. And let's create 3 UI empty entities. We'll name the first one Game Timer UI. We'll name the second one Waiting for Players UI. And we will name the last one Create Winner UI. So for this first game timer, this will just be a timer for our UI, and we will anchor this to the top. We'll have a Y pivot of 1. And we'll zero this out. Let's give this maybe negative 150. It seems a little too much, maybe negative 100. And let's set the width to something like 200, maybe 250. And then let's add a sprite GUI renderer component as well as a text component. For the sprite GUI renderer component, let's find some RUID that we like. Let's go with this one. And for the text, we will use this for the timer, so we'll just set this to 99. And we will increase the font size to something like 30, maybe 40. Let's set the padding for the positioning a little bit better. And we will add an outline to this. Let's give it a black outline, and let's set the font color to white. Let's give it a drop shadow, and we'll decrease the distance down. And now we have a timer. For the Waiting for Players UI, we will also anchor this to the top. We'll set the white pivot of 1, and we will give this maybe negative 200. And then we will give this 600 width with maybe a 200 height. And we will add a sprite GUI renderer, and we will add text. This text could be something like 40, and we will say waiting for players, ... I think this frame is a little bit too big, so we'll shrink it down to maybe 100. And we'll give it a little bit nicer looking frame here. Let's say this one. And then finally, we have our winner UI. Let's set this to the top as well, but let's maybe set it to, we'll also set the pivot to 1, and maybe give it a negative 250, maybe negative 300. And then we will set the height to 200 and the width to 400, maybe 500. And then let's add 2 more children to this. The first one we will name title, and the next one we'll name winner text. We'll just name this winner. And then for our add component, we will do sprite GUI for our frame. And let's give this another frame here, maybe that one. And let's also add UI area particle. And we'll set the particle type to star field simple. Let's set the area offset down a little bit. And we will increase the area size out a little more. And then we'll set the color to maybe bluish glow. We'll set the title up to the top. We'll set it to 0. We'll set it to 1 for the pivot. And for the Y, we'll set it to maybe -5. We'll set the height to 50. Maybe 75. We'll increase the width to be the full width. So we will actually zero out the sides here. Let's add a text component and we will say congratulations. We'll increase the font size to maybe 30. We'll make it bold. We'll make it white and we'll give it a drop shadow. And for the winner text, we will set to stretch to the bottom. We'll zero out the left and right sides. We will set the white pivot to 0 and we'll zero out the positioning. Let's position the Y up just a little bit and let's increase the height just a little bit more. And let's add a text component. And let's set this to username is the winner. And we will replace username with the text that we like. We will increase the font size a little more. And with that, I think we have our UI. So let's disable both our game timer UI and our winner UI. And we will just keep the waiting for players UI. And we will create a new component, Zakum UI component, and we'll add that to the Zakum UI group. We'll open it up. The first thing that we need to do is we need to add in some of the events that we have started from our game manager. So remember, we had our game start event, we had our game end event, and we also had a count event. So we will listen for our timer event, we will listen for our game start event, and we will listen for our game end event. For each of these, we will be listening for the logic script, and let's search for game manager. And because each of these events are being sent to the self, which is the logic script, in our UI component, we will listen in on the game manager through the logic type. We need all of these variables being passed in, so we will uncomment these parameters coming in from these events. So first, let's handle the timer event. So we will create a new method. We will name this setTimer. And each time our handle timer event runs, we will call the setTimer, and we're going to pass in a timer value, and we will call self.setTimer, pass in the timer value. We'll make sure that our execution space setting is a client side. And then we will add a property here, and we will not sync. And we'll grab the entity for our game timer UI, and we'll grab from our Zakum UI group, our game timer UI. And let's just add our other ones while we're at it. We'll set all of these to entity. We'll name the next one waiting for players UI. And we'll assign this to the waiting for players UI. And the last one we'll name game winner UI. And we'll assign this one to the winner UI. So from our set timer, we want to first make sure that our game timer UI is enabled because it starts out as disabled. Then we want to make sure that our waiting for players UI is false because we are no longer waiting for players if the game timer has started. Then we're going to grab the text component of our game timer UI. So we're grabbing this component here, and we are going to set the text value to the timer. So that should take care of our timer. Then we'll also add in our waiting for players. So let's create a new function and name this waiting set waiting for players. And we'll make sure that the execution space setting is a client side, and we will enable our waiting for UI players, and we will disable our timer. So this will be when the game is over, and we want to disable our timer and re-enable our waiting for players UI. We also want to have two more functions for showing and hiding the game winner UI. So we will have show winner, and we will have hide winner. For show winner, we will add a parameter of type string, and we'll pass in the username. And then we want to enable our game winner UI. We want to grab the winner text, and we want to grab this text component, and we can grab children of entities by using getChildByName. And then finally, we will assign the winner text to the username, and we will concatenate that with is the winner. And then in our hide winner, we will simply set this to false. We'll set the execution space settings for both to client side. And then from our game start event, we will hide the winner. And then from the game end event, we will enable the set waiting for players. And then we will grab the user entity based on the winner's user ID. If the user entity exists, then we will show the winner and pass in the nickname of our player. So this will actually be the username of our player. So in player component, we also have access to the nickname, which will just give us the nickname or the username of the player. Okay, with that being said, let's test everything that we have so far. Let's go into our Zakum UI, and we'll double check to make sure that we have default show enabled. So we'll check that so that at the beginning of our world start, we will have waiting for players UI enabled. So let's press play and give everything a shot. So we have our first player, and we have the waiting for players UI showing up. We will add in our second player. And our second player is now loaded in, and we have our waiting for players UI showing up. And we can enter into our portal. And the waiting for players UI still remains because we don't have enough players quite yet. Then once we have our second player enter into the game, we can see that our timer now switches out. And the timer counts down from 10 to 0. And then once the timer is done, we get the Zakum helmet, and we have a lot of speed, and we can have someone else steal it. And now we're a lot slower. At the end of the game, we have our congratulations UI show up with the name of the user showing up on text. Perfect. So the final things that we want to implement is the countdown text, the 3, 2, 1, and then the start UI. And then we also want to have the finish UI show up at the end. So we will have a couple of variables defined for our UI effect elements here. We will have 3 variables, and we will choose to sync none of them. The first one will be a string, and we'll name this game start effect RUID. And this will be the effect for when we start the game. So let's go into our resource storage, and under MapleStory resources, we will make sure the etc tab is selected, and we will search for start. And we can see this animated sprite showing up. We can copy the RUID, and inside of the Zakum UI component, we can paste this RUID right in there. The second one will also be an RUID, and this will be the game end effect RUID, and this will be the opposite. It'll be the end, and we'll search for end, and we'll find this one here. We'll copy the RUID for that, and we'll paste that into the game end effect. We'll spell this properly. And for the last one, this will be a table of 3 different RUIDs for the timer. So we will have this as a table, and we'll search for 3 RUIDs. So we'll have this as a table, and we will name this timer effect RUID. And then we will initialize these RUID on initialize. So we'll do self. And first we'll make sure that we have our execution space setting for client, because these effects will be played on the client. And we will do self.timer effect RUIDs equals, and then we'll have open and close curly braces. And the first effect, we'll search for count. And we have a couple numbers here. We'll copy 1 into the first one. And then For the second one, we will copy 2. And for the third one, we will copy 3. And we have all of the timer effect RUIDs, and we are initializing it on initialize. Okay, so that concludes gathering of all of the effects that we need for our timer. So let's create 3 methods. We'll have 1, 2, and 3. And each of these will have a client execution space setting. The first one we will name game start effect. The second one we will name game end effect. And the last one we'll name timer effect. Okay, so to play these effects, we are going to utilize the effect service, and we're going to do the play effect method here. We will pass in our game start effect RUID, self.gamestartEffect. For the instigator, we will choose to be ourselves, so we will do self.entity. And then for the position of this effect, we want it to be at the center of our screen, wherever it currently is. So if the player is moving around, this effect will kind of follow the center of the screen as our character moves around. So to do that, we'll have one more method here, and we'll name this get screen center position. And the return type of this will be a vector3, and we'll return UI logic dot screen to world position. If we right click on UI logic and open API reference, we can see that we have a screen to world position, and we also have the screen height and screen width. So what we need to do is we have to convert the screen height and width into a world position where we can spawn the effect into whatever world position correlates to the center of our screen. So we're going to get the screen to world position, and we are going to create a new vector2. And for the x coordinate, we will do UI logic dot screen width divided by 2. So that's half of the width. And for the y, we will do UI logic dot screen height divided by 2. So that's half of the height. And then because we are returning a vector3, we will at the end of this do 2 vector3, and this will now get us the center of our screen in world coordinates. So we're going to spawn in our effect into the center of our screen, wherever the center is, and we will do self get screen center position. For the position of our object, we will have a 0 rotation, and we'll have vector3.1 for the scale. We'll copy this, and we'll do the same for our game end effect, except this will be the game end effect RUID. For the timer effect, this will be a little bit unique, where we want to individually play each of these count numbers, 3, 2, 1, as long as our timer is currently 3, 2, or 1 to grab the corresponding index. So what we'll do is we will take in the current timer, and we'll do if timer is greater than 0 and the timer is less than or equal to the size of our self.timer effect RUIDs. Then we'll do effect service.play effect, and we'll get the self.timer effect RUIDs, and we'll use the timer as an index, and we'll do self.entity as the instigator, and we will do the center position again. So we'll do self.get screen center position, and we'll have 0 for the rotation, and vector3.1 for the scale. Okay, so now we have our game start effect, game end effect, and our timer effect. And now we just have to call them from the relevant functions. So for the timer effect, we will add that to setTimer, and we will do self.setTimer and pass in our timer. And for our game start effect, we will do that from the game start event. So we'll do self.gameStartEffect. For the game end event, we will of course do that from within the game end event. Game end effect. We'll save everything, and let's give it another shot and press play. So first player, we'll add ourselves into the game. Second player, and for our second player, we will add him into the game. Okay, so we had a little bit of a hiccup. Instead of setTimer, I called the wrong function. So we should not call itself again. This kind of an error is called an infinite recursion. And what we instead need to do is call our timer effect. So now that we are properly calling the correct function, let's press play again. We'll add our first player, and then wait for our second player to load in. We'll enter into the portal, and then we'll count down from 10 all the way down to 0. We can see our countdown timer showing up, and the start effect showing up. Then at the end, we can see the countdown timer showing up again, and we have our UI as usual. Okay, so at this point we have everything in our game, and we have UI as well, but there's one thing missing: sound. Nothing is actually playing when we do anything. There is no audible interaction at all. So let's make it a little bit more interesting by adding the last piece of our puzzle, sound. So let's begin by adding some background music to our world. And if we search under the audio clip, we can go into BGM, and we can kind of click through these and find one that we like. But I already have one that I've favorited, and I like this RUID and this BGM, so we'll copy this RUID, and under our map we have a sound component, and we can see that we might have a different audio currently within our world right now, and if we try playing the audio, you can see that it plays a different sound, but we can replace it with the RUID that we like, and we can check BGM and we can click audio play. And then now, if we press play, we can see that the BGM is playing perfectly. Now, beyond the BGM, we also want to be playing certain sound effects at different positions and different timings. So let's begin by keeping a list of all of the RUIDs that we want to play in the form of a logic script. So we will create a new logic script, and we will name this logic script sfxlist. And we'll open this up, and we'll create a couple properties here, and we will choose to sync any of them. And we'll use this logic script as a global way to access RUIDs across all of our scripts. So we will have them all as strings. The first one we will name steal Zakum. And for these kind of global variables, I recommend using all caps as a way to distinguish global variables from local ones, but that's a programming choice. We will name the second one winner. We want to have an effect play when we win the game. We also have a sound effect play when we start. We have a sound effect when the timer counts. We have a sound effect when we enter the portal. And that's all of the sound effects that we will be using in our world, so we will get rid of these two extra ones. For the steal Zakum RUID, we can go into the resource storage, and under my resources, we can search for a certain effect. And maybe we can search for the hit effect, and then we can play through a couple of these and figure out one that we like. But for when we steal the Zakum, I want a sound that kind of sounds like we're transforming. So I think this one sounds good, so we'll copy this RUID and we'll paste that into our steal Zakum. For the winner, we will search for win. And this first one sounds perfect, but you can look through some of these other ones and see if there's one that you'd like. I'm going to copy this and paste that in. For the sound effect that we want to play when we win, for when we start the game, I want to search for start. And we can play through a couple of these, but I like this one, so we'll copy this RUID and paste it right into our start. For the count, we can search for hit. And let's search through a couple of these. This one sounds nice under the etc. tab. It kind of sounds like a little clicking time, so we'll copy this RUID and we'll paste it into the count. And then for the portal, we will simply search portal. I think that sounds okay, so we'll copy this RUID and we'll paste that into the portal. And then we have the list of our sound effects that we want to use throughout our world. So now that we have the list, now we need to reference them and actually play them. So we will create a new logic script one more time, and we will name this Sound Manager. And this logic script will be in charge of playing all of the sound effects in our world. So first we will have the standard play SFX, and we will pass in the string of the SFX that we want to play. And to play a sound, we will utilize our sound service. And from there, we will play sound, and we'll pass in the SFX, and we'll have a volume of 1. We also want to have a way to play sound effects at specific positions. So we will play SFX at position, and we will add in our string of the sound effects. And we will also have another parameter of type vector3 of position. Both of these will be client-side functions because we want to play them for the client. But for the play sound effect at position specifically, we want to get the local player and make sure that this sound effect is playing so that the local player is listening to the sound effect. So if another player, let's say, played an effect, then that sound would sound far away if my local player is far away from the source of the sound. So we'll use user service to grab the local player. And now that we have our local player entity, we will use sound service again to play sound at position. And we will pass in our SFX. We'll pass in our position. We will pass in our local player as a listening entity. Then we'll have a volume of 1. Okay, so we have a way to play the sound effects, and we have a list of the sound effects. And now we just have to put those together to actually play and call these functions from the various parts of our scripts. Before we move on, there's one mistake that I made. We need to make sure that our string argument is SFX to match the value that we're actually passing in. And one place that we want to play our sound effect is in our game manager when the player teleports into the starting area. So when they use the teleporter and they teleport to the starting area, we will call sound manager, and we'll call play SFX at specific position, at the position where the player is using the portal. So we will call our SFX list, and we will grab the portal sound effect, and we will pass in the player dot transform component dot position. So this will play the portal sound effect at the position of the player that used the portal, and the listener will be the local player. The next place that we want to add our sound effect is at the countdown. So every time the timer goes down, we want to play a sound. So we will do sound manager again, and we will call play SFX, and we will get the SFX list dot count. And that's all we have to do there. The next place that we want to add it is in game start to add our game start sound effect. So we'll do sound manager, play SFX, and we'll do SFX list dot start. When our game ends, we want to have the game end sound effect being played. So we'll do sound manager dot play SFX, and then we'll do SFX list dot game dot winner for when we display the winner. And the last sound effect that we have is going to be on our Zakum player component, and that will be when the player steals the Zakum. So this will be when the player transforms into the Zakum. So in here, we'll do sound manager, and we'll do play SFX at position, and we'll pass in our SFX list dot steal Zakum, and it will be at the self dot entity dot transform component dot position. So we'll play the steal Zakum sound effect at the position of the person that is going to be the new Zakum, and the sound effect listener will always be the local player. So whatever client it is, the local player that heard the sound will hear the sound. So if the player that got the Zakum helmet is far away, then to this local player, it will sound a little bit far away. And that should be it. Let's press play and let's bring everything together. So we have the BGM playing. Let's add in our second player. Let's move our player into the portal. And the portal sound effect is working fine. Let's move it again. You can see the portal is working fine. You can also see the timer sound is working just fine as well. And the transform effect is also working. When we steal the Zakum, you can hear the sound effect for our Zakum. Then when we win, the win sound effect is also playing as well. Congratulations on reaching the end of this series. I really had a lot of fun walking with you through this series, especially had a lot of fun creating this world with you from scratch. So where do we go from here? Well, for starters, rewatch this video and its contents. We've gone through a lot of information today, and chances are you won't fully understand everything the first time. Each section of this video is split into timestamps based on the subject, and I really want to challenge you to consider this project as a rite of passage and learn everything contained within this project inside and out. Don't just copy code and paste it in and be happy that it works. Really understand what's happening behind the code. If there's a specific function or service that I mentioned that you don't fully understand, dig through our documentation, search for certain keywords, and find guides that go into detail of the topic that you want to learn about. If you've recreated this project and feel confident that you understand its contents, pat yourself on the back because now you can officially call yourself a developer. Everything you learned through this series should be enough to start diving in and exploring our documentation and API library on your own to implement your own original ideas. I really want to acknowledge all the hard work it took to reach this point, and I hope that you will continue to explore the MapleStory Worlds platform beyond what we learned together here, and expand your knowledge and creativity into a completely new world with your own unique style. I'll see you out there in MapleStory Worlds. I can't wait to see what all of you create.